5.1, addition and subtraction with like denominators. This is crucial when we talk about like denominators because so far we've seen when operating with fractions, all we've done so far is multiplication and division of fractions and mixed numbers. But when we add and subtract fractions or mixed numbers, we have to have like denominators. Of course, before we called these common denominators. Now, the unique thing about this is once you get common denominators, if we go back to what fractions show us, like the denominators tell us the sizes of the pieces, okay? So, I mean, if you think about this a little bit more concretely, right? So let's see that these are two pizzas. For some reason, this one's cut into fourths, and this one's cut into eighths. We'll see that the sizes are the same, but the pieces are different sizes, okay? Well, let's say that on this one, on this first one, you got two pieces that are left over, right? These two pieces, and then over here you got three pieces like this. Okay. Now, let's say you wanted to put these into the same box. I mean, just to even figure out how, if you have no space, you'd have to start comparing these in the same size pieces. Well, it's the same thing when we add and subtract fractions. You have to have the same size pieces. So before we combine these two pieces, you'd have to make two extra cuts on these. And then you see, well, the pieces are the same size. Here's 4, here's 3, and there's 8 of the pieces, so that'd be 7/8 when we combine them. So that's why you see when we have the common denominators and we're adding or subtracting that the denominator does not change. We're not taking the denominator and adding it to itself. All we do is add the numerators, or if it's subtraction, we subtract the numerators. That's it. The denominator will stay the same, but it has to be the same first. If the denominators are different, just like we see with these concrete examples, we can't simply add the two together. So simplify when possible in the end. Usually that would happen in the end, which we'll see some examples of that too. So here's our first problem, and yeah, we see common denominators of 11, and we should expect to only see common denominators in this section. Remember, if the denominators are the same, and we're using addition in this case, keep it the same. Now the operation addition, it will stay the same, and those two numerators, 2 and 7, we're going to add those. Okay, now when we get this, again, it still will not affect or change the denominator, but the numerator, we can add those. 2 plus 7 is 9. Now again, it said this in the last slide, we should look to simplify here at the end. 9 and 11, 9 is divisible by 3, but 11 is not, and 11 is prime, so that's as far as we go with 11, which means that this is already fully simplified. Alright, so a problem like this one, once again, we're looking at addition, but we see that the denominators are the same, so when we add these together, the denominator will stay the same. Again, the denominator here is communicating the sizes of the piece, and the numerator, how many of those pieces we have. So even though we're adding these two together, it will not change the size, and that's the denominator, so it stays at 27 right there. Now this one's an addition problem again, so we're going to stay with addition. The two numerators, 5 and 4, need to be added. And so 5 plus 4 there in the numerator, I get 9, and the denominator once again will stay. So I get 9 over 27. Now at this point, like we said in the last problem, we should look to simplify it. 9 over 27, and 9 and 27 are both divisible by, well, 9. Which is going to further simplify this fraction into 9 divided by 9 is 1, 27 divided by 9 is 3, and that's about as far as we can take this one. Now, I'll point this out right now, although I would kind of want you guys to use this, especially while we're getting used to this addition and subtraction of fractions. A lot of students skip this step. And what they'll do is they'll just say, well, look, I showed some plus sign right there, and that's my work. And that's acceptable, by the way. And that's acceptable because the denominators are always the same. If the denominators are not the same, which won't happen until the next section, then we're going to have to force them to be the same. But for now, once you get them to be the same, just in order to show work, like it was a quiz or something like that, this is all you'd have to do. I am showing this step so that hopefully it solidifies that we're just adding the numerators right here. But if this works better for you, then feel free to do that too. All right, 5/7 plus 1/7, no problem, because the denominators are already the same. Once again, in the next section, they will not be the same, and we'll have to force them to be the same. But for now, they're not, or for now, they are the same. So, once again, we're looking at addition here. I'm going to keep the operation, but the two numerators, that's what I'm going to be adding, 5 and 1. 5 plus 1 there in the numerator, I get 6, and once again, the denominator is not changing. So I get 6 over 7. This cannot be further simplified, so that's as far as we can take this one, too. So here's our first subtraction problem. That's okay. And again, we'll look to simplify if we can. But when we're subtracting or adding, the denominators, as long as they are the same, is not going to change the denominator unless we look to simplify. So on this one, where we look at subtraction, we're going to keep it as subtraction. Two numerators, that's what we're going to be subtracting. And yes, the order of the subtraction does matter, whereas the addition did not matter. So it's always the first numerator subtracting the second numerator. So that's why we got 72 minus 61 here. So what do we get from 72 minus 61? We'll show the work for this. 2 minus 1 is 1, 6 minus 1 is 1. So that's our new numerator, 11 over 67. Make that a better 7. There we go. Yeah, 67 is not a multiple of 11, and 11 is prime. So, wow, that's as far as we can go on this one. All right, this is a good example. And yeah, we're using subtraction on this. The denominators are already the same, which makes this extraordinarily convenient. And hopefully we like that right now. So our denominator is going to stay the same as 15. At 15, we are subtracting this time. And it's 96 minus 81. First numerator minus the second numerator. So 96 minus 81. Let's show that subtraction down here. Yeah, something unique happened. 6 minus 1 is 5. 9 minus 8 is 1. So what do we end up with on this? The numerator is 15, but the denominator is also 15. And we know that fractions are division. And anything divided by itself is 1. Now, usually we would make that a phantom 1, but we have to have something to hold to show the value of this thing. So our final answer here is just 1. Now, this is why it's crucial to simplify, or that you always check in the end if you can simplify. Whereas when we were multiplying and dividing, it's possible to simplify in the beginning or even in the middle of the problems. But with with subtraction and addition, sometimes you won't know if it can be simplified until you get to the very end. All right, this indicated operation is subtraction, so we'll do this one, and we'll simplify if it's needed. Once again, we have common denominator, so we're going to keep it same denominator of 6. On this one, we're looking at subtraction, so we're going to subtract the two values 5 and 1 in the numerator. 5 minus 1 specifically, because order does matter with subtraction. So we'll have our denominator of 6. 5 minus 1 is 4. And yes, 4 over 6 can be simplified. These are both divisible by 2. So this ends up being 4 divided by 2 is 2. 6 divided by 2 is 3. And yep, that's as far as this one will go as well.